Hello everyone, and welcome to CRPS Contender, my Complex Regional Pain Syndrome education channel. Today we will be covering, in the interests of not dying, a healthy immune system. Now this is a primer level for my Autoinflammation and Autoimmunity mini-series. So if you are unfamiliar with what your immune system is, or how it functions in a basic manner, this is going to be a good crash course, or if you have studied this in the past, but it's been a while and maybe you've forgotten, this will be a good refresher. If you are looking for videos that are more CRPS specific, go ahead and check out levels 1 through 4 of my ANA mini-series. Each progressive level is a bit more robust and in-depth than its predecessor. So let's hop right into what a standard immune system is and how it operates. The first thing to know is that your immune system has 3 layers of defense: physical barriers, non-specific response, and a specific response. Let's talk about physical barriers first. Physical barriers include things like your skin, your tears to keep your eyes clear, mucus to protect your nose, throat, and mouth, cilia, these are little hair-like tentacles that line your passageways to capture pathogens or foreign bodies and prevent them from becoming problems. Your stomach acid, which will do as acid does and disintegrate invading bodies. Urine to keep your urethra clear of bacteria or nasties and keep you from getting UTIs or other infections. And friendly gut bacteria. Your second line of defense is a non-specific response. This non-specific response is going to be produced by granulocytes, macrophages, dendritic cells, and mast cells. This is going to be the response that will be given to any invading body or pathogen that makes it past your first physical barrier. And then finally, you have your specific response. Now this comes from your lymphatic system, specifically the T and B cells that reside there. This is your final layer of defense and is only used in specific sets of circumstances. Let's discuss your lymphatic system first. Your lymphatic system is responsible for balancing the fluids within your body, producing immune cells like B and T cells, and removing toxins and waste from your body. Your lymphatic system looks very much like your vascular system, which is your blood vessels running throughout your body, and it winds around and within your blood vessels, particularly at the capillaries where they become very, very small, fine little blood vessels that are very thin, that allow things within your blood vessels to move out to your surrounding area, which including the cells and the interstitial space between the cells. Your lymphatic system is responsible for collecting extra fluid that is put out from your vascular system. Once that fluid is collected, it gets moved into your lymphatic system where it becomes lymph. Now, lymph is the combination of lymphocytes and that extra interstitial fluid, which is the fluid from between cells, that it picks up. That fluid then gets sent to your lymph nodes where it is checked for pathogens. You have 2 major arms of your immune response: your innate system and your adaptive system. Let's start with your innate system first. Your innate system might also be called a few other names. It might also be known as your natural immune system or your inherited immune system. This is your second line of defense against invading pathogens. This is your immediate, non-specific response. Second, you have your adaptive immune response. This might also be called your acquired or humoral immune response. This is your final specialized defense against specific pathogens. These are pathogens that your body will learn and memorize so that if you ever encounter them again, you can immediately deal with them in a permanent sort of way and not get sick a second time. Because this requires learning patterns and finding specific responses, this can be a delayed response. Now, you've probably heard the term white blood cell before. Your immune cells are white blood cells. These are also called leukocytes, which is the proper medical term for them. There are different kinds of leukocytes. The first category I want to talk about is granulocytes. Now, granulocytes are a category of cells that contain little granules, almost like little tiny itty-bitty pieces of sand on the inside, that they can then release to provoke certain kinds of responses from your body. There are several different kinds of granulocytes. The most common kind is neutrophils. Now, neutrophils are your first responders. They primarily attack bacteria, and they work in large numbers. They are there to overwhelm the enemy with sheer force of numbers, but they are quite easily killed. And even if they don't die attacking a pathogen, they die after a few days and are frequently replaced by your body. Neutrophils are produced in the bone marrow but live in the bloodstream. Your least common granulocyte is your basophils. These are also the largest granulocyte, and they primarily are in control of asthma and allergy mechanisms. They contain anticoagulants, which prevents your blood from clotting, and vasodilators, which encourages your blood vessels to open wide. They are also produced in your bone marrow. And then finally here we have eosinophils. These are acid-loving cells that primarily eat worms and parasites. These also produce antihistamines, so you can kind of think of them like naturally occurring Benadryl. They control allergy and asthma mechanisms and are also produced in your bone marrow. And then finally, mast cells. Now, these are not normally considered part of the granulocyte family, but they do release granules, and for sake of space, I'm going to include them here on this slide, but just know, generally they are not considered part of the granulocyte family. In charge of immediate allergic reactions, they accumulate in injured and inflamed tissue where they can either amplify or suppress inflammation. They are produced in your bone marrow, but they live in connective tissue. Now, connective tissue would be things like tendons, ligaments, and your blood is also connective tissue. Another type of white blood cell, now remember these are also called leukocytes, that you deal with frequently are macrophages. A macrophage literally just means big eater. Macrophages are scavengers that go throughout your bodies looking for and eating pathogens and foreign bodies, but they will also eat worn out, dying, damaged, or dead cells and debris from around the body. Macrophages are essential for an innate immune response, the initiation of your adaptive immune response, wound healing, and muscle regeneration. Now, normally when people think of macrophages, your mind will probably go to the killing cells that eat pathogens. But there are actually two kinds of macrophages, a kill type and a repair type. The kill type is known as an M1 macrophage, and it is pro-inflammatory, kills bacteria, and eats foreign bodies. However, you also have your repair type, which is an M2 macrophage. This macrophage has anti-inflammation properties, participates in wound healing and tissue repair. Macrophages are produced in your bone marrow and live in connective tissue and are found in almost all tissues throughout the body. Next, we have dendritic cells. Now, do pay attention to dendritic cells because we will be discussing them quite a bit in future presentations. Dendritic cells are the masterminds of the immune systems. They are in charge of immunosurveillance. They are widely distributed throughout the body, but are in fact quite sparse in numbers. Dendritic cells are the immune cells that link your innate and adaptive arms of the immune systems and help them coordinate their responses. They are specialized for the capture, processing, and presentation of antigens. Now, antigen just means a toxic or foreign body, that's all it means, to the T cells to see if an adaptive immune response is necessary. Now, there is a fine equilibrium in dendritic cell regulation between tolerogenic and inflammatory states. Now, tolerogenic means you're on standby mode, you do not have an active immune response. An inflammatory state is up, ready, raring to go, an active immune response to purposefully deal with an invading body or a foreign substance. If you are unable to keep that equilibrium between the tolerogenic and anti-inflammatory states, you end up with an autoimmune disease. The balance of your immune defenses and self-tolerance is critical to the proper physiological function and general overall health. Now, self-tolerance is the ability of the body to recognize its own cells and leave them alone. If you are intolerant to your cells, you end up killing your own cells because you think of them as harmful and invasive. Now, those are all cells that participate in your innate immune response. Let's shift over to your adaptive immune response. You have 3 major kinds of cells in this response: natural killer cells, B cells, and T cells. There are also more lymph-residing dendritic cells that can also be activated in an adaptive immune response, but since we just covered dendritic cells there, I won't discuss them again. Let's start with natural killer cells. Natural killer cells prevent viruses from multiplying within protected cell walls. Let's say you're dealing with a virus and your innate immune system couldn't handle it, it was completely overrun, and some viruses got past your innate immune system and infected particular cells. It is there within the safety of the cell wall, multiplying rapidly, and once it reaches a certain point, it will burst free from the cell and infect the rest of your body. Your natural killer cells are there to prevent this. They go around and they find compromised cells and they basically stab them to death by puncturing the cell wall, which causes both the cell and the pathogen to die. Now let's discuss B cells. B cells remain naive and immature for quite some time, but once they are activated, they mature into plasma and produce antibodies. They are primarily responsible for secreting antibodies which recognize pathogens and cling to them, marking them for macrophages or other leukocytes to eliminate and prevent cell infection. The important thing to note is that antibodies do not kill anything. They are simply there as signals or flags, markers to differentiate problem areas for other cells to come and deal with in a quick and efficient manner. Some B cells become long-lived memory cells that memorize and recognize exact pathogens so that in the future, if you were ever to be reinfected with that particular pathogen, you could launch an immediate adaptive immune response and hopefully not get sick a second time. B cells develop and mature in your bone marrow. Now let's discuss T cells, and for the purposes of CRPS, these are probably going to be our most important type of lymphatic residing cell. There are multiple different kinds of T cells. All of them together are responsible for regulating your immune response and directly killing infectious agents. They are also your main source of cytokine secretion. Cytokines are a wide variety of substances which are released by certain cells to have an effect on other cells, mainly within the immune system. There are specific kinds of cytokines called interleukins that are released by one leukocyte to affect other leukocytes. But the broader category for that is cytokines. Here are your 4 different kinds of T cells. Probably the most famous one is your killer T cell. Now these are cells that kill other cells, and they directly kill virus-infected cells. These are also called CD8+ cells. Another well-known one is helper T cells. Now these are lower in number than your killer T cells, but they are absolutely essential. They are required for almost all adaptive immune responses. They aid other cells, activate killer T and B cells, and macrophages. Without helper T cells, no defenses can be raised against even normally harmless microbes. If your helper T cells are not working properly, you end up with severe problems. For example, people who have AIDS have severe problems with their helper T cells. You also have memory T cells, like your memory B cells. These recognize patterns of pathogens and live for a long time to help coordinate future immune responses. And then finally, you have your regulatory T cells. These cells are responsible for differentiating yourself from the other, and these prevent autoimmune disorders and attacks against the self. T cells are a bit unique because they develop in your thymus, but they live in your lymphatic system. Your thymus sits behind the top of your sternum, kind of in between your lungs. Thanks so much for watching. I hope you learned something here in this video today, or were reminded of things that you had learned in the past. If you like the content I'm creating on this channel, why don't you go ahead and hit that subscribe button and ring the bell. If you would like to contribute to my medical expenses fund, my Patreon is CRPS Contender. Some relevant sources will be linked in the description below, and I recommend you check out the rest of my ANA mini-series to see how autoinflammation and autoimmunity interacts with CRPS. See you next time. Hello everyone, and welcome to CRPS Contender, my complex regional pain syndrome education channel. Today we will be covering, in the interest of not dying, a healthy